Hey everyone, so I'm going to teach today about definite integral. This is the last part of what I need to teach you, okay? Indefinite integral, this is what the last two previous videos are about, is how to anti-differentiate a problem that is ax to the power of n. Now, this is f of x dx, and this is the rule that you've been learning, how to anti-differentiate. This is a Tuesday, this is Thursday's session. And for some of you who came on Friday, then I also retaught definite integral as well. Okay. Now, what's the difference between the two? Firstly, this is just to find out the, remember I said this is the area function. Doesn't tell you the area. This one tells you the area. Okay. The difference between the two, if you think about it visually, one will tell you if this was the function, the area under the curve. Okay. Obviously, there's different areas between different points, like the area from here to here, between this point to this point, the area would be different, okay, versus the area from this point to this point, the area under the curve would obviously be larger. So when you anti-differentiate, this actually just gives you an area function. However, in definite integral, it's exactly the same concept, okay, it's exactly the same concept. The only difference is you are now finding it between 2 points. So it could be from this point to this point. Then the question is, well, what is the area between those 2 points? Which let's call this A and call that B, which is what the definite integral is about. They say that you're going to find out the area between A to B. Notice that A is on the bottom. We call this your lower limit, or lower bound, whatever you want to call it. Okay? Lower bound slash limit. Simply because A occurs first. You see, A comes first before B, so A is obviously the smaller value versus B, because if x equals A, then obviously x equals B is greater than x equals A. Okay? So B is the upper limit, and this just tells you the area between 2 points. Okay? So your anti-differentiating is still going to be the same. The only difference is you're just going to you're going to find it between two intervals. Okay? So let's do an example. Let's say I want to find the anti-differential. I'll show you the differences between the two. Okay? Let's say f of x equals to 3x squared. If you're finding the area function, okay, so the area function will equal to the antidiff of 3x squared dx. Well, we know, using the rule in definite integrals, we know how to anti-differentiate, which gives you 3x to the power of 2 plus 1 over 2 plus 1 over the plus c. That gives you an area function where x is x cubed plus c. Okay, I'm just going a step ahead. Alright? That doesn't tell you the area. That tells you the function. Okay? Now, in definite integrals, okay, so this is, I'll just write it again, this is indefinite, this is definite. Definite integrals, same concept. Okay, let's say the same thing, same function is 3x squared, but I want you to find the area between, let's say, x equals to 0 to x equals 1. Okay, now I want to know the area between those 2 points. Alright? Now what you're going to do is you're going to say, alright, well, same thing. Area, okay, the area is actually going to equal to between 0, which is a small number, up to the upper bound, 1, of 3x squared dx. Same concept, no difference. The only difference is in your presentation now, is that when you're anti-deriving, there is no plus c. Okay, and the reason why is the c's will cancel out anyway, because when you anti-differentiate, you'll have a plus c, but when you're minusing, because remember the indefinite integral right here, you're going to minus them anyway, so the c's will cancel out. Okay, so here we go. If I anti-differentiate, it's between 0 to 1. I already know the antiderivative of 3x squared, which we found in this problem before, which is x cubed. Okay? So if I solve for that, this tells me something. This tells me, okay, well, Let's solve it. 1x cubed. We are going to say, according to the rule, this is what they said. They said it's f of b minus f of a. Now notice I'm using capital F's here. These are capital F's. What's a capital F for? This is your capital function. Remember I said, if this is little f, you anti-differentiate, this gives you your capital F. So what are they really saying? They're just saying, well, if this is your capital F, then f of 1 minus f of 0 is just equal to 1 cubed minus 0 cubed. See, all I'm doing is I'm just substituting the values in. And if I do that, that now gives me 1 minus 0 is the 1 unit squared. Okay? That just tells me the area. See the difference between the two? This one gives me an area. This one gives me a function for it. If I draw it visually, 3x squared, what does 3x squared look like? Well, this is what 3x squared looks like. It looks like this. Oh, passing through the origin, of course. And I'm saying from 0 to 1, I want to know the area. And in this case, I know it's 1. I wrote units squared because I don't know what the units is. Okay, if it was in centimeters, it would have been centimeters squared. If it was in meters, it would have been meters squared. Okay, so I just don't know what my area units are, or length units are. Okay, so that's what you're really doing there. That's the definite integral. You're just substituting the endpoints in, okay, or the intervals in. So I do another example, okay, just so you get the feel of it. Let's say I do B. Let's try out is exercise 23D. Let's have a look. Let me do this one. Let's say I want to find the antiderivative of 1/4 of 2x plus 5 dx. Okay, this is question 1H of 23D. Okay, so let's have a look. If I want to do this problem, same concept. I'm still going to antiderive like I normally do. This is still 2x to the power of 1 plus 1 over 1 plus 1 plus 5x to the power of 0 plus 1 over 0 plus 1. So I'm just anti-deriving each one individually. Okay? So anti-diffing them individually. Notice my notation, I'm writing 1 to 4. Okay, there's no plus c's because I'm finding the area this time. Okay? So equals 2, let's simplify that down. That now gives me 2x squared over 2 plus 5x. 4, but 2 plus 1. Okay? So now I know it's actually just equal to x squared plus 5x. Okay? So that's pretty simple and straightforward. Now, the next part is, that's anti-deriving. Okay? But remember, when you anti-derive, this tells me f of x. So I know the next step is to find out the area. We're going to use what we call the fundamental theorem of calculus. F of 4 minus f of 1. For now, I'm not going to actually teach you why this is true. This is technically a theorem. It's a fundamental theorem. Of calculus. And you will learn that in year 12. For now, I'm just teaching you how to use it. You'll learn the theory later on, okay? Otherwise, you can YouTube the theory as well. But here we go. Let's come back to the theory. Let's say you know the theory now. We're going to apply it. So f of 4 just means I'm going to sub 4 in to my equation, which is 4 squared plus 5 times the 4. That's subbing 4 in. Minus, now subbing 1 in, it's going to give me 1 squared plus 5 times 1. Okay? Working them out individually, 4 squared is 16 plus 20, which is 36, minus 1 plus 5, which is 6, which gives you 30. Okay, so that's how you do definite integrals. Okay, that's all you really need to know for chapter 23 in preparation for your SAT. Now, I've already posted up some worksheet for 23D up onto the portal. Check that out, and any other notes I've posted up onto the portal. Okay, that's for preparation for the SAC on Tuesday. Alright, so send me any Edmodo messages and I'll try to answer them ASAP. Otherwise, you've got tomorrow's revision to ask me questions as well. Okay, cheers.